Okay, in this video we will continue on with the beginner's guide to SDL2 in COBOL. In the last video we created a text and we moved it around the screen. In this video we will create a player sprite and then we will control the player sprite with keyboard presses. So if you are just joining this video, you're going to need to clone the Git repository, Programming Rainbow. It's at github.com, Programming Rainbow, Beginner's Guide to SDL2 in COBOL. You'll need to clone that repository. And since this is the 7th video, we are continuing on from the source that we were working on the 6th video. So you're going to want to grab the source that's in the 6th video folder and you're going to want to put it into the source folder so you can work on it and follow along with this video. Okay, so let's just show where we left off. We have this text moving around the screen. Let's see, make rebuild run. How about that? Okay, so I have this text that I created with the font, the Free Sans bold font called COBOL, and it's just bouncing around the screen. So we're not actually controlling the movement. So this time we're gonna be loading up our own player sprite, getting its rectangle, and then moving it with a different style key presses that we were doing before. And that's going to be the first thing that we're talking about here. So in the past, we were checking keyboard. Let me just show you real quick. Down here in the, so we have this check input down here, and that is a procedure. Where is it at? This procedure here. And what this procedure is actually doing is it's checking the event queue, and the event queue is telling me did some kind of action occur since the last time that we've gone through the event queue. So these event actions are like a keyboard press. So don't think of it as the keyboard, the key is down, but think of it as an action from the key being up to the key going down occurred. Or you could even check if a key went from down to up. So that's an action, and that's not going to be helpful for us when we're trying to move things around the screen, because you're gonna get this here. If you can see the text on the screen right now, I'm going to press B, and you're going to see one B show up, and then it's going to pause, and then B will start repeating. So there, and then it starts repeating, and this is a problem because we don't want that to happen. What we want to happen is we want the game to just update if the key is actually just in the down state. Is it being pressed down? I don't want to know if there's an action or if that action has been simulated to repeat because of the keyboard. I just want to know, is the key down so I can do the thing that I want to do in this frame? So we are not going to be using a key event for this. We're going to be using something else. So there is something in the, there's an internal array in the SDL. When SDL gets loaded up, it creates an internal array of your keyboard. And this array is indexed by the scan codes that we've already seen here. These scan codes, and even better, they're actually indexed by the, see this A would be 4 with the enum. So it's an enum. So if I were to take this kind of array and index this array with the number 4, it would tell me, is the A key up or down? Because that would return a 0 or a 1. 0 would mean it's not being pressed, and 1 is mean it is being pressed. And this isn't an action. This is just what the state of the board is in right now. So this array will have all the keys that we can use. So now the problem comes in is interfacing this array with COBOL. So we're going to do something similar to what we did before. We're going to be making it an array in COBOL, and we're going to be mapping that pointer to this internal pointer. So this internal array in SDL, I want you to understand that this is not an array we're making, and it's not an array that we are going to be managing. It's an array that's actually created by SDL2 when it initializes. So we just need the pointer to it, but we are not freeing it or anything like that. It's not our array, it's SDL2's array, but we just need a pointer to it. We need access to it, and we need to be able to index into this array. So the way that we're going to do this, so we're going to be doing something very similar to what we did before with the events and stuff, and how we're kind of reassigning it. We'll go over here. We're going to go to the working storage section, and I'm going to put it below where I've done this SDL event It's going to be something similar to that, but it's going to be simpler. So give myself some room here. So this one we're going to call it key state, and it's going to be based again because we're going to reassign the way that we did it with the buffer for the string coming back, because that was just a pointer to a string that was being held in C. So this again is a pointer to an array. I mean, string is just an array. So this up here, the way we did this error buff right here, and we base this, so we can redirect the pointer of this whole thing and map it on top of an array from C. We're going to do this exact same thing right here. But we're going to be doing it for this, instead of an array of characters, a string that's coming back from C, which is the character array. We're going to be doing it for this keyboard array. So we're going to call it 0, 1, and we're going to call it key state. And I'm using this based. And then we're going to go 05, and I'll call this key state array. I'll just say R. And usage. And this is going to be a bind. Okay, so let me show you the array real quick. So this is returning is it's returning a uint8, a pointer to an uint8, which is it's an array of unsigned 1 byte. You know, it's a 1 byte unsigned array. So what we need is for us to do a 1 byte, we're going to say a binary character because that's 1 byte, and we're going to say it's unsigned. So we'll use the binary character, unsigned. And to the best of my knowledge, the size of this array, I don't actually know the size of this array, and it might be different depending on the computer you have when SDL boots up. I'm not actually sure, but this thing goes to 284. It could be bigger than that, or it could be smaller. So what I'm going to do is I'm going to make an array that is 512. We're not going to use the whole array, but we'll be able to index comfortably, and since I don't actually know the size of this array. So I'm going to say occurs 512 times, okay? And so the other thing that is very notable about this is we're going to index into it, but when we index into something in most programming languages, like if we were doing it in C, it would be 0 based. So the very first item would be 0, but COBOL doesn't do that. COBOL is 1 based. That means this number here, this enum, for say A, well, it's not that A, sorry. Well, I know what we're looking for. We're looking for the arrow keys. So the arrow keys are right here, right, left, down, up, right, these ones here. So if this is 79, that would be how I would index it in C, it would be 79. But in COBOL, I need to add 1 to it, so it's going to be 80. So just keep that in mind. When you're whatever key that you want to do this with, you're going to need to add 1 to this because COBOL has a 1 base index, not a 0 base. So we will be setting up these keys. And I'm going to be adding right, left, up, and down, and I'm going to be adding 1 to each of these. So this right, left, up, and down, this is 79, 80, 81, 82. So it's just going to go from 80 to 83. So, or I'm just going to copy these up here. So right where I was doing this one, I just need 4 more of these. And again, this 44 and 41 here, these are correct, but we're using them differently. We are not indexing into them. So if we were going to check if space was down, we would use 45, not 44. But for this one, we are doing it that way, so we need to add 1 to each one. So this will be left, right, up, down. Let me just double check to make sure I have this in the right order. No, it's right, left, down, up. Okay, so I'm going to switch it. Okay, and we know it starts from 80 and then goes to 83. Okay, so this gives us the scan codes to check the keys, and remember that we added 1 to those. And we have this key state array, but we haven't actually linked it up with the internal, the pointer of the internal array. So we're going to do that inside of the initialize, the SDL initialize. And I'm just going to do what I did with the error, which is I'm going to set the address of it. So down in our initialize, I'm just going to go down to the bottom. Under this free surface for the icon. Yeah, that was the icon surface. Okay, so right here, what I'm going to do is I'm going to call this function here. That was the first function I called, this SDL get keyboard state. What this does is it returns the pointer to that internal keyboard. And it says returns a pointer to an array of key states. The pointer returns is a pointer to an internal SDL array. It will be valid for the whole lifetime of the application. It should not be freed by the caller. Okay, so it's its own managed thing. We just need the pointer to it. And this is returning the pointer right here. So here is the function call that we're going to use. And right here, what is this? If non-null receives the length of the... Oh, okay. So we could actually find out how big the array is by if it's non-null, I guess, but I've never done that before. And also we can't dynamically set the size of anything in COBOL, so it wouldn't really be worth anything to us, because I wouldn't know if my system's the same as the next person's system. So we're going to put null in here. That's what we're going to be passing to it. So we have call. That caps lock gets me every time. It moves things around or changes the way things happen. So we're going to be using by reference null. And then we are returning a pointer. We actually we can't tell it to return that key state pointer directly. So it wouldn't work with the error either. So I actually need to make another pointer. So we're going to make another pointer, and I'm going to call it key state pointer. And then we're going to remap that pointer right away. So I'm just going to copy this and call it key state pointer. Oops. I'm covering this quickly because this is the exact same thing that we did with the error in the second video. So we can receive this pointer and hold it as pointer. We can't receive it directly as this, but then we can take the address of this and set it to the new pointer that we've created. We can do that, but we can't return it back directly as key state. So let's go back down here. So this will be returning, and this will be the key state pointer that we created, and that will be the end call. Okay, so what we're going to do right away is we're going to set that address. So we're going to map that pointer to that array that we made. Or we're mapping the array to the pointer, rather. So we're setting the address of key state, which is the one that we created, that array that we created of 512. Key state, we're going to map it to this pointer that we have. Key state pointer. And that will set up, now we have access to the key state of for SDL. Okay, so that wasn't as bad as the other ones, partially because we've covered a lot of this before, and it's much smaller. It's just a single array there. So that's going to give us access. We haven't actually loaded anything and moved anything now, so why don't we do that? And nothing new is happening here. What we're going to do is we're going to load a texture. We've already loaded the background texture before, so this is very similar, but it's going to be called the COBOL logo. We're going to load this texture. We're going to get the width and the height of the texture for our rectangle so that we can display it correctly. And then we are going to use what we just set up to move it during the loop, during its inside of its update procedure. So first thing we need to do is go to, there's no new libraries or anything like that coming in. So we're just going to go straight down to load media. And I'm just going to grab where we loaded the background because this is exactly the same. So where we load the background and check the background, that's exactly what we're doing right now for loading the player sprite. So I'm going to yank that. And down here, this was for, yeah, we're going to be using that as well. And we just need to change the name. So we need to change the name and the file name as well. So I haven't made a pointer for this yet. We'll finish here and then we'll go up and make it. And the pointer is going to be called Sprite image. Okay, and the COBOL logo is what we need to put here. And down here we're checking Sprite image. Okay, we do need to get the width and the height, but the problem is we haven't actually made this Sprite image yet. We haven't made the pointer to it, and we haven't made the rect that this will receive. So before we query this, before I forget, let's go up and create those two. So we need a pointer to the image. We'll put it in our pointer section. And we do need to make sure that we clean this one up. The key state pointer, we're not doing anything with that, but the sprite pointer we do. So we'll call it sprite image. That gives us our actual image pointer, but we also need the rectangle. Okay, so it's very much going to look like this right here, except there's only going to be one velocity. There's not going to be these three because we are manually controlling this one. So I'm just going to kind of grab this, just one of these. And repurpose it. So we'll call this probably Sprite Rect. Yeah, we'll call it Sprite Vel and Sprite Rect. And I'm going to change this from 3 to 5. So our controlled sprite will move faster than the text that is moving on the screen. Not in, okay. There we go. Okay, so I'm going to not set this to anything. So we have a sprite velocity, that's going to be 5. And we have a sprite rect, and it's just all zeroed out for right now. We are going to populate it with the query texture. We're going to do that right now. So, and we have our pointer now that we've already been accessing, but now we've created it. Where is it? It's in the pointers right here. Okay, so down here we've already populated our pointer. It is in we've populated this pointer. We haven't queried it yet, and we haven't cleaned up after it. So before we forget to clean up, let's clean up after it. And this, we're going to clean this up the same way we clean up the background. This is the draw call. Sorry, not the cleanup. Okay, so the same way we clean up the text image texture as well. So I'm just going to take this. And we are cleaning up the Sprite image. So that makes sure we're loading the image and we're unloading it. But we also need to now get our width and our height. So that should be in load media. Is this load media? Yes, it is. So this is just like this query right here. This query, and it can fail. So we need both of these. The way we queried the texture for the text early in the last video. So this time we are querying the Sprite image. And we are getting the width and the height of the sprite, or we're setting the width and height. And our return value, querying texture, this is all just the exact same. So if you didn't watch the last video, you should, but the function call is query texture. It takes in a texture, and what we actually want is the width and the height out of our texture to populate our rectangle, and we're doing it here. And these first, the first thing you need to pass in is the actual image, and it's a pointer, so we're doing it by value because it's already a pointer. And then the next two items we're not using, so we're just sending in by reference null because we're not using those two items. And the last two are the ones that we actually want, which is the width and the height. And this function can fail, so we're checking afterwards if it fails. So now we have an image loaded, a rectangle. We're also unloading it. We have all the pointers set up. We have set up to get information about the keyboard, but we're not using that yet. Let's first draw the image to the screen. So we're going to put it in our draw. And remember, this draws back to front. So we're clearing the render that's on the back. We are drawing a background on top of it, so that's on top of the render, and then we're drawing the text on top of that. So why don't we draw our player sprite on top of that? So it's the exact same thing as this, so I'm just going to copy this right here. And we just need to change the names. So we still receive the render, but we're using the sprite image. And we need the sprite rect. Oh, there's only one T in there. And that should be good enough to draw it. So we should see the COBOL logo, which I think is I don't know what it is, a Triceratops or something. I don't think it's the actual official logo either, but it is just a logo that I found people using for COBOL. So let's hope that no mistakes were made. Okay, there we go. That is our image loaded, and this is the correct size. This is just the default size that it would be. Okay, and we can't move it yet. We haven't set up anything for moving it. We'll do that next. Okay, so just like the way that we made an update, the main procedure, we do inside the game loop, we update the text. We will also create another procedure called update sprite. So I'm just going to put the perform in here, and then we'll make it right away. Okay, so this procedure doesn't exist yet. We need to make it. So I'm going to go down and find the update text, and I'm going to make it after that. right here. Looks good. So we have this update sprite. So this is going to be very simple because we're just kind of, if you've done this in any other programming language before, we're just going to index the array. And we can't call key state. Let's just look real quick at it. So we're not going to be calling this to index the array. We're going to be calling this. We use this to map the pointer that we returned. We map this on top of that pointer. So this is kind of our pointer to this whole thing. But we actually, when we index it, we're using a key state array to index. We got a sprite update right there. So this is going to be an if. Key state array. And we use parentheses to index into it. And then we just need to press, we just need to check a key. Okay. So we can do the, what was the first one? The right key. We can check that, SDL right. Scan code right. It doesn't matter which one we check first. Is not 0, then. So we're basically saying if this is 1, it's being pressed down. So we're just saying, is it not 0? We could also say if it's 1, that would work too. And we're going to add the velocity to the sprite's x. So if we're going right, we're adding our whatever our velocity is, which is 5. We're going to add 5 to what our x is for our rectangle. That's going to move the rectangle to the right. So we're going to say add sprite velocity. This allows us to change the velocity at the top if we ever want it to be something else. To sprite rect x. And then we just end the call, end the add. I don't think there's a period because we're inside of an if sentence. And then we need to end the if. And I'm going to put these all into their own if statements. The reason why is, imagine if I were to do an if else, imagine if I press the left key and the right key at the same time. Well, whatever the first if statement hits is going to be called, and the else will never be checked. So if I have if on the right first, and then I do an else on the left, but if I press the right and the left, it's going to go right. And what I want to happen is it shouldn't move at all, because they should counter each other. So I'm going to make each movement its own if statement. So basically, if right is pressed, it's going to move it to the right, but if left is pressed, it's going to move it to the left too, and it's going to end up back where it was, which is fine. So I'm not going to be using if-else statements. I'm going to just use ifs. So we have if it. So we can do if it's left, we'll just subtract. So we can almost do this same thing. And we could say if array left. Oops, that tab key or caps lock key keeps getting me. So if left is not 0, and we're going to subtract. And then end subtract. And it's from, not to. This should be from. Okay, so that should get us moving left and right. So maybe we just check that first. We are calling the procedure up into in the main game loop. We've already set that up. I'm going to put an exit at the end of this, just so I can visually see where it ends. So we should just have left and right movement, and we can also make sure that the direction is correct on the movement. Okay, so I'm going to press the right key. Yep. I'm going to press the left. And see, it doesn't pause and then start repeating. It just moves. Whenever you press it, it just goes the direction. There's no initial move, stop, and then starts moving again. Okay, so let's add our Y to that. So if we're going to add if it's down, right? So if we're moving down the screen, we're adding to the Y, which is not capitalized. If we're moving down the screen, we're adding to the Y. And if we're going up, we're subtracting. Okay, I'm moving down, moving up. Okay. Now I believe if we do an OR, on this, we might, I don't have this set up in my code, but if we say we wanted AWS, well, let's try it. Let's try just throwing in an OR. Or the key state, we'll use the same thing. We could tell it to be is 1 instead of not 0. I'm just going to copy this. I don't need the if. It should be or. Okay. And then we can have it then. This fit, maybe. Okay, so we need a different key, but I'm just going to try this logic and see if it lets me get away with this. Okay, so let's try, let's get the other key scans for AW and AWSD. I think they're up here. So if we want to move right, we need D, which is 7. A is 4. That's the left and right. So A is 4 and D is 7. Up here. Oops, I didn't want that. So D is the right one. D is the right one. And it was 7, so it'll be 8. We have to add 1. Left was A. I think it was 4. It was either 3 or 4. A is 4, so it'll be 5 for us. And then up is going to be W. And down is going to be S. And we need to check those. So S is 22 and W is 26. 22 and 26. 23 and 27. Okay, so now we have AWSD, or however you say it. And we can go back down to the movement. Let's load, let's draw, colors, update, sprite. Okay. So, and I also want to try it the other way. Instead of saying not 0, we could say is 1. It means it's down. And this is right, so we're going to say D on this. I'm just going to test this one more time right here with this 1 and the D, just to see if I get movement out of it. Okay, it does not like the literal. So the 1 is a no-go. What if I put it? It doesn't matter. I could figure it out, but the one that already works. So let's just try that. Or wait. Yeah, I was thinking maybe something. Okay, so let's just change that to here, and then we'll change it to D. Okay, I'm gonna press D. Okay, cool. So basically, we can do this. I'm gonna copy this, and we can do this for all of them. So left is A, and then down is S, and up is W. Okay. See how that goes. Okay, now I'm going to do D, A, S, W. Perfect. Does it go twice as fast? No, it doesn't. If I press up right in D, it still just goes the same speed. Yeah. So all moves as expected. We do have this faster diagonal direction. It's fine for this simple demonstration video. We're not normalizing direction and using a bunch of higher math and stuff. That's all fine. It all works. Okay. So let's just cover what we went through. I know I glossed over a lot of stuff because we already discussed them in quite detail in prior videos, like the how we're getting the pointer to work and how we're mapping it and all that. But what we did here is we have added the left, right, right, left, down, up, D, A, W, S, and I'm getting all of those from if you just look up scan codes here and you go to the bottom, you get a lookup table, and I'm using those, and I'm just adding 1 because it's 1 based, so we have to add 1 to it. So whatever key you want, just use that 1 and add 1 to it. So that is all of those. We needed a pointer to the keyboard state and to the new image that we're loading in. We also needed to make this keyboard state array. So we have the top level is the keyboard state, under is the keyboard array, which is just 512 unsigned chars, which lines up with the SDL array. So we're doing that there. We also have a velocity again for our sprite and a rect for our sprite. And that's just like what we did with the text moving. So the keyboard state, we're just getting that pointer, and then we're mapping the address of the keyboard state array that we've made to that pointer to be able to get access to it. Load media, we are just loading it as a texture, checking it, querying it, make sure that query didn't fail to get our width and our height out of it. Not doing anything in check input. In the main procedure, up here, we do have a new update sprite. So in our new update sprite that we've just created, we're just indexing it. We're just saying, hey, is this thing not 0? If it's 0, it's up. If it's not 0, it's down. It's either going to be a 0 or a 1. And it didn't like it when I put 1 in. I'm not sure if I put 1 in quotes, if that would work. not 0 works, so I'm just using that. And each one of these are separate. They're not, I'm not doing an if else because I want it to correctly move based on if there's key combinations pressed. And then we are freeing the sprite image. We do need to free that, but we don't need to worry about the pointer that we made for the key array because that is handled by SDL, and that will be cleaned up when we shut down SDL. So I hope you enjoyed this video. Thanks for watching again, and goodbye.